back everyone. In this video we're going to be talking a little bit about significant figures. So I know what you're thinking. You're probably thinking, oh, Sig Figs, you mean people like Neil deGrasse Tyson, famous astrophysicist. Or you might be thinking, oh yeah, significant figures? Okay, Henrietta Leavitt, another astronomer, pretty significant. Or you might even be thinking, Isaac Newton developed calculus at the age of 26, gave us lots of physical laws, etc., etc. Well, that's not really what I meant by significant figures. Instead, sig figs are a way to kind of keep track of the uncertainty involved in a measurement. Okay? So it's a way to track the uncertainty of a measurement. And the reason that we have to do this is that oftentimes we're adding measurements, we're multiplying and dividing, we're doing all sorts of math operations to actual measurements that aren't perfect numbers. So we need to know how to deal with our math operations. So there's a couple of simple rules for significant figures. The first rule is that zeros at the beginning of a number are not significant. So for each of these rules, I'll give you an example. Okay? So the number 0.0254 has 3 sig figs. In other words, the 0.0 are not significant. They're placeholders. They don't tell us any additional information. Rule number 2. Zeros within the number are significant. So, for example, if I write the number 201.6, that has 4 sig figs. That 0 in the middle between the 2 and the 1 is a significant digit. Okay, rule number 3. Zeros at the end of a number are also significant. For example, the number 3750.0 has 5 sig figs, because there's a big difference between 3750.0 and 3750. 3750.0 tells us that we measured that number, whatever it is, with an instrument good enough to allow us to estimate the point 0. So theoretically could have been 3750.1 or 3749.9 or whatever. But the point is, we're able to measure it to that amount of precision, so we have more sig figs. Okay, and finally, zeros at the end of a whole number. So a whole number might be significant. In other words, we don't know. So what I mean by that is, let's say I wrote 500 kilograms. Okay, how many sig figs does that have? Does it have 1 because of the 5 and the 2 zeros are placeholders? Or did I actually measure something to be exactly 500? Not 499, not 501, but exactly 500. How do I know? Well, this is why scientific notation is so useful. So if we write this number in scientific notation, there's different ways to write it. If we truly measured it to be 500, emphasis on the 5, like it could have been 400, it could have been 600, we're not sure, then what we would write is 5 times 10 to the second kilograms, and that's one significant figure. Okay, but let's say we were a little bit accurate and it was really, it could have been 490, it could have been 510, so then we could write 5.0 times 10 to the second kilograms. Well, that's got two significant figures. And what if we actually measured it to the ones place? So it could have been 499 or it could have been 501. It really was that precise. Then we write as 5.00 times 10 to the second kilograms, and that's got 3 sig figs. So when you have a whole number, the best thing to do with it is to write it in significant or in scientific notation, because then you can say exactly how many sig figs it has. So we're going to go on to talk about how to use sig figs in calculations. And the reason that we do this is that if we take two numbers that are measurements and we multiply or divide or add or subtract or whatever, we don't want to write more significant figures than we started with. Okay, we don't want to increase our precision when we do math to numbers. When we do math to measurements, typically the amount of precision that we have decreases. Okay, so using sig figs in calculations. So there's two basic rules. Rule number 1 is when you're multiplying or dividing. So I'm going to write in cursive so I can write a little bit faster. Okay, so when multiplying or dividing, you leave as many sig figs in the answer as there are in the quantity going into the calculation with the least amount of sig figs. So the best way to explain this is with an example. Let's say that we want to multiply, let's say 205 meters. We want to multiply that by 12 meters. So maybe we're calculating an area. So if you actually plop this into a calculator, you're going to get 2,460 meters squared. Remember, we have to multiply the units as well as the numbers. Okay, so this could either have 3 or 4 sig figs, but if we look at what went into the equation, 12 only has 2 sig figs, whereas 205 has 3 sig figs. So what we need to do is to round our answer to give us 2 sig figs. And the best way to do this is to write 2,500, or as we just said, 2.5 times 10 to the third meters squared. So that's using scientific notation. So that's rule number 1. This also works for dividing. I just gave an example for multiplying. Rule number 2 is when you're adding or subtracting. When you're adding or subtracting, you're going to leave the same number of decimal places, rounded of course, in your answer as you have in the quantity with the least number of decimal places. Okay, and again, we need to have an example for this. So let's say that I want to subtract two numbers, 105.0 meters and 29.29 meters. So if I actually do that on a calculator, I'm going to get 75.71 meters. But looking at my rules, what I see is that the first number goes to the tenths place and the second number goes to the hundredths place. Okay? So this means that I need to round my answer to the tenths place. So this turns into 75.7 meters. Now the strange thing about this is that we end up with something that has 3 sig figs, whereas both of our starting quantities had 4 sig figs. So this is a very strange rule, but this is the way that it works. Okay, so that's our quick introduction to sig figs.